Okay, this is my assignment for question 1. Given one period of a predict function as fx equal to x squared and the limit is 0 until 2. Question A. Sketch the graph of the function from 0 until 2. For this question, I will draw a graph x squared first, and then I will draw the graph of the function from 0 until 2 so you can understand better. And the question B, I will explain later for the next recording. This is graph of x squared. After we make limitations, the graph will be like this. As you can see here, there's a limitation at x axis, that is 0 until 2. Question B. Find the Fourier series expansion of the function. For this question, I will use a few formula that is a general formula for Fourier series, and at this question I will use mathematical formula how to express the Fourier series expansion. This is a general formula for Fourier series. As you can see here, there is a naught, an, and bn. 2l is a period of a function. For question 1, the period is 2 because the limit is 0 until 2. To get l, we use a equation like this. 2l equals to period, 2l equal to 2. L is equal to 2 over 2 is equal to 1. This is the final formula for Fourier series expansions. As you can see here, there is a naught, an, and bn. After you get the value of a naught, an, and bn, the value will be inserted into this formula. N's below there is equal to 1, 2, 3, 4, and so on will be used at the end of the solutions. I will explain more the function of n in the question B. This is the formula for a naught equal to 1 over 2l, and the limit is negative l to l. As you can see here, after we solve the problem, the answer is 4 over 3. This is the formula of an. An is equal to 1 over l, integration from negative l to l, fx cos n pi over l x dx. After we insert the value of l and the integration from negative l to l and the value of x, the equation will be like this. To integrate x square cos n pi over 1x dx, we use a formula. The formula is like this. The value of a in this formula is n pi over l. The next step we use is we insert the value of a into the value of n pi. So this is the expression of integration of x power of 2 cos n pi over 1 x dx. The next thing we do is we insert the value of 2 and 0 into x. Cos and pi 2 is equal to 1 because, as you can see in this calculator, cos 2 times any value of n will be equal to 1, and 1 here at the equation is the n value. Okay, I will change the value with 2, so the answer is still 1. I change the value 2 with 3, the answer is equal to 1. Okay, as you can see here, cos and pi 2 will be equal to 1. Sin and pi 2 will equal to 0 because, as you can see here in calculator, 2 minus any multiply by any value, for example 1, and will be equal to 0. Okay, I change the value 1 with 2, 0. Okay, sines and pi 2 will be equal to 0. Anything that is multiplied by 0 is 0. So after we calculate, we get the value here, and the final answer is 4 over, in the brackets, n pi power of 2. This is the formula of Bn, that is equal to 1 over L integration from negative L to L fx sine n pi over L x dx. After we insert the value of L and the integration from negative L to L and the value of fx, the equation will be like this: 1 over 1 integration from 0 until 2 x squared sine n pi over 1 x dx. To integrate x squared sine n pi over 1 x dx, we use a formula like this. The value of a is equal to n pi over L. So we insert the value of n pi over L to the a, and the equation of integration of x squared sine n pi over 1 x will be like this. So we insert the value of 2 and 0 to x, and the expression of the equation will be like this. As the previous example, sin n pi over multiply by 2 is equal to 0 because any number that insert to n is, for example, 1, 2, 3, 4 will be 0. Anything that multiply by 0 will be 0. And cos n pi 2, after we multiply with any value of n, for example 1, 2, 3, 4, 5, the value will be 1. Don't forget to put bracket when you minus with another equation when we insert the value of 0. And after calculate this expression or this equation, the answer will be like this, and the final answer is this. This is the final formula for Fourier series expansions. As you can see here, there is a naught plus sigma an cos n pi over l x plus bn sin n pi over l x. Okay, after that we insert the value of a naught, an, l and bn into this formula. So the equation will be like this. So after that we insert the value of n to the equation. I put value of n to 3 to an or an cos n pi x first, and then I insert n equal to 1, 2, 3 to 4 over n pi sin n pi over 1x. And after the calculation, the answer will be like this. This is the final answer of Fourier series expansion.